this first example. It says determine if the following sets of vectors are linear independent or linear dependent, and hence find the rank. Okay, so after determining that they are linear dependent or linear independent, and then find the rank. Okay, so here we have a vector 1, which how many components this vector contains? 1, 2, 3, and vector 2, 1, 2, 3, and vector 3. And how many vectors do we have? 1, 2, 3. All right, so we can set these vectors to a matrix. Or first thing that is that here these vectors, remember that we said we are going to have a k, which is a k1 times vector v1 plus 2 vector 2 plus k3 vector 3 be equal to 0 when we are checking whether the vectors are linear dependent. Let me copy this and paste it somewhere. All right, there we go. I want to paste here. Yeah, paste. All right. Okay, so let's do it here because we have more space. So we are going to have k1 v1 plus k2 v2 plus k3 v3 is equal to 0. Okay, so we want to find the value of k and of k1, k2, k3 that will make this 0. So we have this as that, and I have this as that, and this as that. Okay, so we can say k1, and we'll open bracket, this is 1, 0, and 0. Okay, so we can say k2 is 0, 1, 0, and plus, sorry, supposed to be plus here, and k3 is 0, 0, 1. This must be 0. And remember that from the system of equations you have this kind of a system of equation, and you can set this to a matrix form where you will have a matrix A multiplied by x, a matrix x, vector x, which is going to give you a vector B. You can do that. So we're going to do the same thing for this one. Going to do the same thing. So actually you have this this is a matrix, this is going to form a matrix. This, the combination of all these vectors are going to form a matrix, and then these are going to be a variable, and then they're going to give us 0, right? So we can say that this is the same as a matrix. We start with this one. How many components we have? We have a 1, 0, 0. For this one we have a 0, 1, 0. For that one we have a 0, 0, 1. This is vector 1, vector 2, vector 3. So all of these, it's multiplied by k1, k2, and k3, and which is going to give you 0, 0, 0, right? So we want this expression, this one here, this one, to give you 0, and we want this one to give you 0, and this one to give you 0. So this, it tells you that here, you see here, this is going to be k1, you multiply by this one. So this means that k1 times k2 times k3 is equal to 0, if you remember the multiplication. So it's k1, this one you multiply by this, plus k2 times 0, which is going to be 0, plus k3 times 0, which is going to be 0, is equal to 0. So we'll end up having k1 here, since it is in the first form, it's going to be k1 is equal to 0. You come here, k1 is 0, k3 multiplied by 0 is 0, and then you'll have to with k2. So in the second equation we have k2 is 0, and for the last one, since it is 2, when you multiply by these 2, they become 0, and only this one is left, which k3 is 0. So you see, this is the only solution we got here. So since if this is the only solution we got, and then we say that these vectors are linear independent. So these vectors are linear independent. These vectors are linear independent. These vectors are linear independent. These vectors are linear independent, and we have, because we have k1 is 0, k2 is 0, and k3 is 0. So it's the only thing that can make the whole this thing to be 0. You have a solution, and then we decide we have how many rows, 1, 2, 3. So we have how many vectors? 3 vectors. So all these vectors are linear independent. So if we call this a matrix A, so therefore the rank of A is going to be 3, because you have 3 vectors that are linear independent. So a rank is just a number of vectors that are linear independent. That's how we're going to define a rank. The total numbers that are linear independent. So since we have the 3 vectors that are linear independent, then that's our rank. So let's go to the second example. This one here. Let me copy this. Paste it here. Okay, so let's do this. Let's take a look at this one. So we have a vector v1, and we're going to do the same thing. You set a matrix using these vectors. So you are going to have, your matrix is going to be, this is, since it's 2 minus 2 and 4, right? And for the second one is 3 minus 5, 4. The last one is 0, 1, 0. And then you know that this is multiplied by k1, k2, and k3, and which is going to give you this 0, 0, 0, right? So you can do that. So what you can do now, you can take this matrix. Remember that this is in a form of AXB, right? So you can take this matrix and reduce it using the row operation. Reduce it to a lower triangle. So when you are reducing it to a lower triangle, remember that you can find easily the solution if this is reduced to a lower triangle, right? So by saying that, it's because you have to use this thing here to get 0 here, and also to get 0 here, and use the second one to get 0 here. Remember, so the first thing that we are going to do, we're going to divide this row. So we're going to have this is 2. We're doing the row operation, and if you don't know about the row operation, please check my videos where I teach about the row operations. Okay, so we have these, and if we're reducing, first we have to take this, we have to divide this by row 1. You have to divide this to 1 here, so which is going to be 1 minus 1, 2, and then 3 minus 5, 4, and then this is still 0, 1, 0. Then now going to the next step. What you must do now, you must eliminate this 3. You must get 0. So to do that, you just say in row 3 is going to tend to let me write it somewhere here. In this matrix here, row 3 is going to, row 2, sorry, not row 3. Row 2 is going to tend to, this is 3, so it's going to be row 2 minus, in order to get 0 here, you must times this entire row by 3, and you subtract it from here. So it's going to be minus 3 row 1. So if it's minus 3 row 1, here we say, okay, 1 times 3, it's 3, and then we say 3 minus 3, which is, this is going to be 1, 1, 2, this is going to be 0, because it's 3 minus 3, and then you times this by minus 1, you get positive 3. So positive 3 times minus 5 plus minus 5 is going to give you minus 2, and then you come here, you times this, you get minus 6, and you say minus 6 plus 4. So minus 6 plus 4, you get minus 2 again. So you have 1 here, you have 0 here, 1 here, and 0 here. So now you must change this one here to 1. So you are going to take this row 2 and you divide it by -2. Okay, so it's going to turn to, here we're going to have 1 minus 1 2 0 1 1 and then 0 1 0. So here you have to reduce this to 0. So when you reduce this to 0 here, you are going to get you're going to say this, you are okay, now I'm reducing this to 0. So what you're doing, you're saying row 3 will turn to row 3 minus row 2. So when you're minusing row 3 by row 2, you're going to change, and this will become 0 1 0 still. So this will become 0. Row 3 minus row 2 0. Row 3 0 minus row 2 is going to be -1. So it's 0 minus 1. And you can do the same thing here for this matrix here and to get 1 here. So what we are going to do now, we're going to find the solution. So let me just copy this, because rubbing it is not an option. Okay, so since I can't copy it, I'll just rub here. I'll rub it there. So this is what we got. Which is a matrix in a reduced form. Initial matrix was 2 minus 2 4 and 3 minus 5 4 and 0 1 1. When you reduce, this was multiplied by k1 k2 k3 which gives you 0 0 0. So where this was coming from here, they are saying k1 times v1 plus k2 times v2 plus k3 times v3 must give you 0. So here you reduced this. So when you reduce, this is in this form now. So this is the same as if you are taking this. Now this is going to be the same as, you are going to insert this matrix is 1 minus 1 2 and then 0 1 0, and then you have no, not 0, here was supposed to be 1. It's not 0, it's 1, and then 0 0 minus 1, and then you multiply it by k1 k2 and k3. That's going to give you 0 0 0. So now we're trying to find k. What's k? Okay, so now let's see. So you can see from there that when you start from here, from this bottom line, remember that we said, okay, then now you can divide this by 1. So that's gonna be the same as we can just remove this minus here. So it's the same as the 0 0 1. Okay, so when you multiply this, now you want to find the value of k. So this, when you take this, you multiply by that, this multiply by that, this multiply by that. So it's like you have a 0 k1 plus 0 k2 plus 1 k3, which is going to be the corresponding value here, which is 0 0. So you can see that k3, it will give you 0. You come here, so here you are going to have already, it's going to be k2 plus k3. You can see that are 1 and 1. So you equate this to 0. K3 is 0, and then k2 is going to be 0 also. You see, so you come here for the first one, k1 minus k2 plus 2k3. So you have a k1 minus this one minus k2 is going to give you minus k2, and then this is going to give you since you have 2 here, so it would be plus 2k3 is 0. Then k1, k3 and k2 are zeros. So now you are trying to find k1. So k1 is just going to be this and 0, this and 0 is 0 also. So you see, this is the only solution that you have. So if it is the only solution that you have a 0, you have a 0, and you have a 0. This is a trivial solution. So you have only trivial solution. Hence, we say that the rank here is linear. The rank of this is going to be the rank of this matrix A is going to be the rank of this matrix A is going to be 3, and then we say these vectors are linear independent. The vectors are linear independent because the only solution that you have is a trivial solution. K1 can be 0, it's here. K1 can be 0, this 0, this 0. That's the only solution you got. Okay, so let's do the last one. The last example. Let me copy this here. Let's do the last one. Okay, so here we have the last one, which is going to be K1 V1 plus K2 V2 plus K3 V3 must be 0. So let's write this time, write this in another form this time. So it's going to be K1, you open a bracket, take a look at this. You have 1 and minus 3, and you add by K2, which is going to be minus 2, and you add by K3, which is going to be 4 and minus 1, right, which is 0. So if you can write this is going to be like you have a K1 here. This is K1, right? It's K1 plus minus this, minus this thing here. So this is K3 minus 2K2, sorry, not K3 to K2, and then this is plus 4K3, so it's equal to 0. You come to the second one, so you have this one for the second one, which is minus 3K1. This one is going to be here was supposed to be comma, it's going to be plus 2K2, then the last one is minus K3, gives you 0. So the one thing that's surprising here, and this is going to arise to a theorem, is that you have this. How many solutions do you have? Like how many trivial solutions you must have? So you must have K1 is equal to something we don't know. You must have K2 is equal to something we don't know. You must have K3 is equal to something we don't know. But how many equations do you have? You have 2 equations. So if you have more unknowns that must be solved than number of equations, those vectors, they're already linear dependent, but you must show that. So by showing that, now we're going to do like this. We can create a system of this or anything. So let's just create a system. Our system is going to be 1 minus 2 4, and here we have minus 3 2 minus 1 is our system. So we can say this must be equal to 0 0 and 0, and we know that is multiplied by k here. I didn't include it this time, but it's multiplied by k. Okay, so here you can see that we can reduce this to 0. So if we reduce that to 0, we're going to have 2 minus 2 4. So by reducing this to 0, we're going to say R2 will turn to R2 minus 2R1. So this is going to be sorry, not plus, made a mistake, supposed to be R2 plus 3R1. So when you add this, you're going to get 0. You get 0, and you times by this, you get 6 minus 6 plus 2, which is going to be minus 4. You do the same thing here. This you get 12, then you say 12 minus 1, which is minus 11. So you have 0 and 0. You have 2 zeros. So you take this. So this is like minus 4k2 as we know, plus minus 11k3 is equal to 0. So when you're finding k2, so here let's just let k1 or k2, let k3 be t. So t is element of any real number. So we are saying minus 4k2 is going to be minus 11t is equal to 0, and then minus 4k2 is equal to 11t. So k2 actually is 11 over 4t. This is what you're getting for k2, 11 over 4. So you go to k1. So if it is k2 is 11 over t, and you can see that k3 already, you said that k3 is t, and then k2 is 11 over 3, and then k1, and then this is minus 2 from here, minus 2k2, and then we'll have this plus 4k3 is equal to 0. So here you have k1 minus 2, 11 over 4t plus 4t. So when you're making k1 the subject of the formula, obviously you're not going to get this was supposed to be 0, since it's going to be 11 minus 11 over 2t plus that, you're going to get, also you get minus 3 over 2t. Oh sorry, it's going to be plus. When you bring to the other side, you get plus 3 over 2. So let's write our values for t1, t2 and t3. So we found that for this to be true, you have k1, k2 and k3 being 0. This is a trivial solution. It's a solution that we already know that if you plug 0 0 0, we'll get zeros. And you have another solution that if k1 is 3 over 2t, where t is any real number, and k2 being 11, is it, yeah, 11 over and k3 being t, you're going to get 0 also here. You're going to get 0. This is going to be true. So therefore you have two solutions, which one is a non-trivial and then the first one is a trivial solution. So you are going to say that these vectors, so therefore these vectors are linear dependent, dependent. Okay, so you can see I showed you the linear dependent system and linear independent system. So there's one thing that two theorems that you must know also, because sometimes you don't have to even to check, you just use the theorems and then you